Good morning. Today I'm going to do a quick review of the calorimetry equation and the density equation for those of you who still have some questions about it. So let me go ahead and share my screen with my document camera. So remember that the calorimetry equation is Q is equal to M times Cp times delta T. That Q refers to energy or heat, and the unit we put there is joules. So if you're reading a word problem and it has joules, you know that it'll go into the Q equation, the Q part of the equation. M stands for mass, which is going to be in grams. Delta T stands for the change in temperature. Did it get warmer? Did it get cooler? How much did it change? So that's in Celsius. And then our last variable is Cp. Cp stands for specific heat capacity. And its unit is joules per gram degrees Celsius. A couple of common heat capacities. Water has a heat capacity of 4.184 joules per gram degrees Celsius. Iron has a heat capacity of 0.46 joules per gram degrees Celsius. Aluminum has a heat capacity of 0.91 joules per gram degrees Celsius. And I could go on. You have a whole list of these in your digital interactive notebook. But the trick to doing these problems is as you read the word problems to focus on the unit. For example, let's say I was asked this question. How much energy is required to heat 120 grams of water from room temperature, which is 25 degrees, to boiling, which is 100 degrees Celsius? So you always want to start by using your formula, so it kind of reminds you what goes where. Q equals M times Cp times delta T. And then you look for your numbers and your units. So the very first number I come to is 120 grams. Remember that we said grams will go into the M variable. So I'm going to put the 120 grams here. The second number I come to is a temperature, 25 degrees Celsius. And according to my problem, my water is going from 25 degrees Celsius to 100 degrees Celsius. So what is the difference in those temperatures? That's what we want to put in delta T. So it's always going to be the largest temperature minus the smallest. Remember that these are absolute values. And what I mean by that is energy can't be negative. It can be transferred. So one thing loses the energy and the other gains it. So we never talk about delta T's as negative, just as a neutral absolute value change. So that delta T is going to go here. So you'll notice I still have two variables missing, my Q and my Cp. Well, I can get the Cp, you can get the Cp from the table in your digital interactive notebook, or sometimes it's provided in the problem. In this case, we're going to remember that the heat capacity of water is 4.184. That's in your table. So I can put that right here. And now I am ready to solve for Q. I'm simply going to multiply 120 times 4.184 times 75, and I'll find out that the amount of energy it'll take to heat that water from 25 to 100 is 37,656 joules. Not too hard. So you can also be asked to solve for one of the variables on the right. For example, let's say that I have this problem. What is the mass of a 95, what is the mass of a piece of aluminum if 1,500 joules of heat, by the way, we do use heat and energy interchangeably for joules, increases its temperature 28 degrees Celsius. Now, a lot of times you are given two temperatures and you'll just subtract the difference, but other times you may just be given the delta T directly, like in this case. So remember, we always want to start out with our formula, Q equals M times CP times delta T. And then we're going to find our values in the problem and decide where to put them. So the first number we come to is 1,500 joules. Well, where do joules go? In Q. So I'm going to put the 1,500 joules on this side of my equals. Mass, what is the mass? That's what we don't know, so that's the variable I'm looking for. 28 degrees, well, that's going to go in my delta T. And once again, I still need to figure out what heat capacity to use. Because this is an aluminum item, I'm going to use the specific heat capacity for aluminum. Those are just constants. And once again, you have a table of those in your DIN. And now I'm ready to isolate my variable, which in this case is M. So I'm going to simplify each side first. So 0.91 times 28 is 25.48 times my M. And then of course, to get the M by itself, I'll simply divide both sides by that 25.48. So that when I do the math, 1,500 divided by the 25.48 gives me a mass of 58.9 grams. So we can solve for anything on the right or the joules on the left just by plugging in the numbers and focusing on using that formula. You also do need to remember what goes in each of those units. Joules goes in Q, grams goes in mass, and the degrees Celsius will go in temperature. And the heat capacity is usually found in that table in your interactive notebook, or it'll be provided to you in the problem. I believe on the practice test and test, well, I know on the test it'll be provided in the problem. So the only other formula that we've been using right now is the density formula. And so remember, the density is just mass divided by volume. And you can rearrange this to solve for mass. If I wanted to get mass by itself, I'd simply multiply both sides by volume. So mass is equal to density times volume. And then lastly, I could isolate volume by dividing both sides by density. So volume is equal to mass divided by density. And so the only trick to density problems is remembering that the unit that goes in mass will be in grams. The unit that goes in volume will be either milliliters or centimeters cubed, because those are the exact same thing. And then density is either communicated as grams per mil or grams per centimeter cubed. You can use either one of those, it's fine. So, for example, if I was asked, what is the density of an object with a mass of 18 grams and a volume of 9 mils, I'm simply going to use my density formula. Density is mass over volume. And of course, my mass in this scenario is my grams, so 18 grams. And my volume was 9 mils. So that when I do the math, I figure out that my density is 2 grams per mil. You can also, like I said, solve for a mass if you have a density and a volume, or a volume if you have a mass and a density, by using these rearrangements of the formula. I hope this was a little helpful. Always start with a formula and think about what units go where. That's the easiest way to solve these. So I hope that if you missed this the first time, that'll help clarify it a little. And good luck.